When we gaze up at the night sky, we often imagine planets orbiting distant stars, perhaps not so different from our own blue marble. But what if I told you that, scattered across the cosmos, there exist planets so bizarre, so utterly alien, that they challenge everything we thought we knew about how worlds are born and evolve? Today, we're embarking on a countdown of the strangest, most mysterious exoplanets ever discovered. Planets that push the boundaries of our imagination and rewrite the cosmic rulebook. From planets with not one, but 3 suns setting on their horizon, to worlds shrouded in darkness, darker than the blackest coal, these exoplanets invite us to reconsider our place in the universe. Each one is a cosmic riddle, a testament to nature's creativity, proof that the universe is far more inventive than any science fiction writer could hope to be. Together, we'll journey to these far-flung corners of our galaxy, exploring the weird, the wondrous, and the downright unthinkable. So buckle up, fellow wanderers. From triple sunsets to zombie worlds, let's explore the weirdest corners of our galaxy. The universe is stranger than fiction, and tonight, we're going to prove it. Imagine standing on the surface of a planet, gazing up at the sky as not 1, not 2, but 3 suns set in a dazzling ballet of light and color. This is the tantalizing promise of HD 188753 AB, a world that, if it exists, orbits within a trinary star system, a place where every day ends with a triple sunset. It's a scene right out of a science fiction novel, but in our universe, reality often outpaces imagination. The story of HD 188753 AB begins with its home, a complex stellar system located about 149 light-years from Earth. 3 stars are locked in a gravitational dance, circling each other in a cosmic waltz. Now add to this a Jupiter-sized planet whirling around the primary star, its skies illuminated by its 2 stellar companions. The physics of such a configuration is mind-boggling. How could a planet possibly form in such a chaotic, gravitationally turbulent environment? Astronomers were stunned when they first announced the discovery of this planet. Conventional wisdom said that the immense gravitational forces from the 3 suns should have prevented any planet from coalescing at all. Planets, after all, are fragile things, born in the quiet cradles of dust and gas that encircle young stars. In a trinary system, those cradles are rocked and torn by the tides of multiple stars, making planet formation seem impossible. Yet, the evidence seemed persuasive at first. HD 188753 AB became a media darling, touted as the Tatooine planet, reminiscent of the famous Star Wars world with its double sunsets. But as more data poured in, doubts began to surface. Was this planet real? Or had astronomers been fooled by the complex dance of its 3 suns? The signals were faint, the data noisy, and soon some researchers began to question whether the planet existed at all. This uncertainty is in itself a testament to the mysteries of our universe. Sometimes, the act of discovery is messy, filled with ambiguity and second guesses. HD 188753 AB stands as a reminder that the cosmos doesn't give up its secrets easily. Whether or not this triple sunset world exists, its story has reshaped our theories about planet formation in multiple star systems. If it does exist, imagine the view. 3 suns, each rising and setting in its own rhythm, painting the sky with colors and shadows we can barely imagine. Seasons would be wild, tides extreme, and the definition of a year would become an exercise in celestial mathematics. Even in uncertainty, HD 188753 AB teaches us a profound lesson that the universe is not limited by our expectations. It's a place where the improbable not only happens but sometimes becomes the norm. So, as we move forward in our countdown, remember HD 188753 AB, the planet that may or may not be, but whose very possibility forces us to rewrite the rules of what's possible in the universe. If HD 188753 AB challenged our ideas about where planets can form, HD 80606b redefines what a planet's orbit can be. While most planets glide around their stars in gentle, nearly circular paths, HD 80606b has a wild, comet-like orbit that takes it on a 111-day journey of extremes. Imagine a planet careening toward its star, swinging perilously close, then flung far out into the cold reaches of its system, over and over, every few months. This eccentric orbit brings HD 80606b from a chilly, distant aphelion to a fiery, close encounter with its sun, where it experiences a temperature swing of nearly 1,000 degrees Fahrenheit in just a matter of hours. For much of its orbit, the planet is shrouded in darkness and cold. But as it races inward, its atmosphere is blasted by intense starlight, causing catastrophic storms and violent shock waves that rip across its skies. Astronomers have watched in awe as the planet's atmosphere responds to this cosmic roller coaster. When HD 80606b nears its star, its upper atmosphere heats up almost instantaneously, triggering winds that race at thousands of miles per hour. These atmospheric shockwaves are so intense, they would dwarf even the worst hurricanes on Earth. The planet's clouds are torn apart, only to reform as it swings back into the cold. The physics driving these storms are the stuff of nightmares and dreams for planetary scientists. It's a living laboratory for studying how atmospheres respond to extreme changes in temperature and radiation. On HD 80606b, the weather isn't just unpredictable, it's chaos, written across the surface of a gas giant. What's more, the origin of this wild orbit remains a mystery. Did another planet or star give HD 80606b a gravitational shove, sending it onto this eccentric path? Or does its story hint at a more tumultuous past? A record of collisions and cosmic near misses written in the language of orbital mechanics? For any hypothetical visitor, the experience would be harrowing. One moment, you'd be freezing in the outer reaches of space. The next, you'd be blasted by heat and light, your world engulfed in ferocious storms. The planet's year is a story of survival, adaptation, and transformation, a cosmic drama that plays out over and over. HD 80606b isn't just an oddity, it's a window into the processes that shape planets across the galaxy, its orbit, its storms, its extremes. These are clues to how worlds can change, evolve, and sometimes survive against all odds. When we peer at HD 80606b through our telescopes, we're not just seeing a planet, we're witnessing the universe experimenting with the rules. And in that experiment, we find both beauty and chaos. As we move deeper into our countdown, let's remember, the universe rarely settles for the ordinary. Sometimes it prefers a wild ride. Our next stop is a world that shouldn't exist, a planet orbiting the remnants of a dead star. PSR B-Tal 57 plus 12 is known as the Zombie Planet, and its story is as eerie as it is fascinating. Imagine a world bathed not in the gentle light of a sun, but in the deadly strobe-like pulses of a neutron star, a pulsar. It's a place where life, as we understand it, would be utterly impossible. Pulsars are the corpses of massive stars, collapsed into dense, spinning beacons that sweep the cosmos with intense radiation. When a supernova ends a star's life, it's assumed that any planets in the vicinity would be vaporized by the explosion. Yet, PSR B1257 plus Hus12 hosts not just one, but 3 planets, all orbiting a pulsar that emits bursts of radiation with clockwork precision. The environment here is nothing short of hostile. The pulsar's beams sweep across its planets like a cosmic lighthouse, except, instead of guiding ships to shore, these beams would fry any living thing with lethal doses of gamma rays and X-rays. Night and day are meaningless. Instead, the sky flashes on and off with each pulse, creating a strobe effect that's both mesmerizing and terrifying. How did these planets survive? Or more intriguingly, did they form after the star's death, rising from the ashes of destruction to orbit the pulsar like cosmic phoenixes? The answer remains a subject of debate, but either scenario challenges our deepest assumptions about planetary systems. For a long time, astronomers believed that planets couldn't form around pulsars. The discovery of PSR B1257 plus 2's planets in the early 1990s shattered that belief, opening up new possibilities for where and how worlds can emerge. In this system, we see the universe's capacity for regeneration, even in the aftermath of cataclysm. If you could stand on one of these zombie worlds, you'd witness a sky unlike anything on Earth. The darkness would be punctuated by blinding flashes, and the ground would be scorched by invisible waves of radiation. No familiar constellations, just the relentless mechanical heartbeat of a dead star. The existence of planets around pulsars raises profound questions about the resilience of matter and the unpredictability of creation. Even in the universe's most hostile environments, nature finds a way to surprise us. So next time you look at the night sky, remember that some worlds are born in death, orbiting the cosmic remnants of stars that once shone bright. The zombie worlds of PSR Beta C57 Plus 112 are proof that, in space, endings are just another kind of beginning. Imagine a planet so dark, it absorbs almost all the light that falls upon it, darker than the blackest coal, blacker than any substance found on Earth. This is TRES-2b, a gas giant that orbits its star just 750 light-years away, and yet it remains almost invisible, a ghostly shadow against the backdrop of space. TRES-2b's atmosphere is a cosmic enigma. Unlike the reflective clouds of Jupiter or Saturn, this planet's clouds swallow light, reflecting less than 1% of the starlight that hits them. It's as if the planet were painted with the universe's most perfect black paint, a world that lurks in perpetual twilight, even as it orbits close to its sun. Astronomers believe that chemical compounds in the planet's atmosphere, perhaps vaporized sodium or potassium, or even light-absorbing titanium oxide, are responsible for this inky darkness. But the truth is, we don't fully understand what makes TRES-2b so black. Its existence forces us to rethink what planetary atmospheres can do. Despite its darkness, TRES-2b isn't entirely invisible. It glows with a faint, eerie red, thermal radiation leaking from its superheated atmosphere, which reaches temperatures higher than any oven on Earth. This ghostly glow is the only clue to its presence, a subtle hint that something lurks in the shadows. If you could somehow visit TRES-2b, you'd find yourself enveloped in a night so complete, you'd lose all sense of direction or distance. The horizon would vanish. The only light would be the dim, hellish red that seeps from the planet's own heat. It's a place that defies our senses, a world that hides in plain sight. The discovery of TRES-2b is a reminder that not all planets are bright, shining jewels in the night sky. Some are masters of disguise, cloaked in darkness, challenging us to find new ways to detect and understand them. In studying TRES-2b, we're forced to confront the limits of our technology and imagination. What else might be hiding out there, cloaked in the universe's deepest shadows? The darkest world teaches us one of astronomy's central lessons. The universe is filled with surprises, waiting just beyond the reach of our eyes. Our final stop brings us to a planet that spins to the beat of its own drum, WASP-17b, also known by its mythological nickname, Ditso. This gas giant orbits its star not in the same direction as the star spins, but in reverse, a retrograde orbit that defies our understanding of how planets are supposed to behave. In most solar systems, planets form from a swirling disk of gas and dust that encircles a newborn star. Everything spins in the same direction, like dancers moving in sync around a central partner. But WASP-17b bucks the trend, circling its star the wrong way, as if it were moving against the flow of a cosmic river. This backward motion isn't just a curiosity, it's a challenge to our theories of planet formation. How did WASP-17b end up on this retrograde path? Did it suffer a colossal collision with another planet, or was it captured from another system altogether? The answers are still unfolding, but one thing is clear. Ditso is a cosmic rebel. Named after a mythological trickster, WASP-17b lives up to its reputation. Its retrograde orbit suggests a tumultuous past, Perhaps marked by gravitational encounters and dramatic upheavals, the planet's very existence forces astronomers to reconsider the stability and instability of planetary systems. WASP-17b is also enormous, one of the largest known exoplanets, and it's astonishingly light for its size. Its atmosphere is puffed up, bloated by the heat from its close star, making it a true giant among giants. Every revolution it makes is a reminder that the universe has a knack for the unexpected. If you could sit in a spaceship and watch WASP-17b's orbit, you'd see it racing in the opposite direction of the star's rotation, a cosmic dance that seems to break all the rules. The planet's year is just 3.7 Earth days, a dizzying pace for such a colossal world. For scientists, WASP-17b is more than a curiosity. It's a laboratory for testing our models of planetary dynamics and migration. Every observation, every measurement helps us build a fuller picture of how worlds are born, move, and sometimes rebel against the order we expect. WASP-17b reminds us that in the universe, even the most fundamental rules can be bent or broken, and in those exceptions, we find new opportunities for discovery. As we've seen tonight, the universe is not content with the ordinary. From triple sunsets to planets shrouded in perpetual night, from zombie worlds to cosmic rebels, each of these exoplanets challenges what we thought we knew about the cosmos. They are reminders that the universe is more imaginative and more mysterious than any fiction we could invent. So, which of these strange worlds captured your imagination the most? Was it the triple sunset of HD 188753 AB, the wild storms of HD 80606b, the eerie zombie planets of PSR B 1257+12, the pitch black mystery of TARI S2b, or the backward rebel WASP-17b? Let me know in the comments below. I'd love to hear which planet you found the most mind-blowing. If you enjoyed this journey through the weirdest corners of our galaxy, be sure to subscribe to Wonder Theory for more mind-blowing space discoveries. The universe is filled with wonders yet to be found, and together, we'll keep exploring its endless possibilities.